Hi. All right, modeling inequalities. This is our second and last video for this particular lesson. So lesson 3.6, modeling inequalities, if you just showed up. So we have this situation here. Now remember, all of these, like this stuff as well as the last video, we don't have equal signs in here. We're going to have an inequality. So a basketball team scored 8 points more in its second game than its first. In its third game, the team scored 42 points. The total number of points scored in the 3 games was more than 150. So our Pac-Man is going to be eating our points and not this 150. What is the least number of points the team might have scored in the second game? So let's put a little work into this. If I look at these sentences, I need to identify what is a variable in here, what does that variable mean, and then I need to sort of set up my inequality. So numbers that I need to pay attention to. We have 150, and we need our other points to be more than 150. We have the third game being 42 points. The second game is 8 points more than the first game. So I don't actually know how much the first game is in terms of points. So that means that's my variable. So my variable is the first game, and I'm going to say that's X. So let's start writing this down. We have our first game, X, plus, and it's a total of all 3 of these games, first, second, and third games. We're putting them all together. So we're saying all of those points are more than 150. So our first game is X. Our second game is 8 points more than the first. So that means this is my first game. My second game is X plus 8. And then my third game is 42 points. And all of this has to be more than 150. More than 150. Now notice it says more than, not more than or equal to, more than. So, I mean, there's some limitations on this, a little bit more extreme limitations than we saw in the last problem. So now I'm going to do a little bit of work, and I'm going to get tiny. So X plus X, that's 2 X's. 8 plus 42 is 50. That's more than 150. Let's solve this. I'm going to subtract 50 on both sides. I get 2x is greater than 100. And I'm going to divide by 2 on both sides. So I get x is greater than 50. So that means my first game, if I were to think about this, my variable was the first game. My first game is greater than 50, so that's 51 points. All right, so 51 points at least in the first game. So now let's focus on the problem and the task at hand. What is the least number of points the team might have scored in the second game? It's the least number of points the team might have scored in the second game. So if I were to say the first game has to have more than 50 points, the smallest number that could be is 51. So X could equal 51 or more. Its smallest amount is 51. The second game is 8 points more than the first game, so I'd have to add 8 points to that. So the second game is at least 59 points. Now, you might be thinking now, if I say the second game is 59 points, if we put all of these numbers back into this original inequality, we'd get 51 plus 8 plus 42. And when I solve that, I get 152. And 152 is definitely more than 150. But when I first solved this problem, I was thinking to myself, like, could I get 151? Could I get a little closer to that? Like, could that work? And the answer is no. And the reason why is because this first game has to be more than 50 points. The first game has to be. And if our second game is that same amount the first game is plus 8, that means we're not just adding like 2 more than the 150 or 1 more than the 150. We're adding that 1 more to 2 of those variables. So really, there's 2 more than we're going to be. So the closest we can get with this second game is 59 points. It's not going to be 58, because if it was 58, that would make the first game 50 points, and the first game has to be more than 50 points. Kind of fun, kind of a nice little bit of reasoning that I was playing around with in my head as I went through this. But sometimes that reasoning really helps me sort of confirm my suspicions with the problem, or confirms my gut instinct with the problem. So consider like playing around with that when you're working through these problems. I feel like inequalities really require you to justify your reasoning, at least in your head, a little bit more than a typical equation does. So have a blast now with the must-do problems, and then complete the exit pass, and you will be on your way to greatness. Bye.